All right, continuing on, as examples are going to get tougher and tougher, as again we're looking at finding our horizontal asymptotes, vertical asymptotes, and potentially oblique asymptotes, and then determining what behavior is going on around those asymptotes so we can sketch a graph. So a little more complicated examples here. Again, looking at the VAs. Actually, I might as well do the HAs first. They seem to be less involved. In this case, we have a degree of 1. They're equal. And a degree of 1 in the denominator and the numerator. So I divide the coefficients. 4 divided by 2. I get a horizontal asymptote at y equals 2. Vertical asymptote. Alright, and so again I'm looking at the denominator. What number would work here to make it equal to 0? 1 would work. Check it out in the numerator. Whoa, 1 works too. So we don't have a vertical asymptote. What we do have is a hole at x equals 1. Okay. Oblique asymptotes doesn't happen because the degree isn't of the numerator isn't exactly 1 higher than the denominator. Now here's where this question is a little bit of a trick. I'm trying to show you every kind of example that you can get. Alright, and what I can do with our equation here is I can simplify it. Now I've already established with this hole at x equals 1 that for this function x cannot equal 1. But I can simplify this function because I can factor out a 4 on the top, so I have an x minus 1. I can factor out a 2 on the bottom, so again I have an x minus 1. Now because I've stipulated that x can't be 1, I can divide these two out, otherwise I would be dividing by 0, which you can't do. And I get a line here of y equals 2. So that is actually our function. So the horizontal asymptote doesn't really exist because this is our function. And so this is what this graph looks like. I have the y equals 2 line, but there's a catch. So there's our line, but then at x equals 1, there's a hole there. Oh, should have put that 2 there. There we go. And so there's what our rational function looks like. It's just a horizontal line that happens to have a hole at x equals 1. So no limits involved there. A little bit different example. Again, I like try to switch it up for everything. Show you everything possible. Alright, now next up. Example 4. Y equals 3 divided by x squared minus 4. Again, I'm looking at horizontal asymptotes first, this time out. Again, I look and see that the degree of the denominator is higher than the numerator. So y equals 0 is an asymptote. Vertical asymptotes. Now this is where things get interesting. Is I look at the denominator. How could it be 0? A 2 would work. So an x equals 2. But also because it's squared, negative 2 would also work. Alright, so now here's the issue. That we're going to be doing 4 limits. We're going to do 2 limits for x equals 2 and 2 limits for x equals negative 2. So I have the limit as x approaches 2 from the left-hand side. Again, that's what the negative sign means. Whoops, minus 4. So I'm just writing out our function. We're also going to find the limit as x approaches 2 from the right-hand side, so 2 positive. So again, there's our function, 3. We got x minus 4 in the bottom. We'll figure out what those limits are. We also have the limit, where am I going to write this here? We got the limit as x approaches negative 2 from the left-hand side. Again, I'm going to write my function. And my other asymptote, still going on with x equals negative 2. I'm going to approach it from the right-hand side. There we go. Alright, so we'll find out what hopefully our graph there doesn't run into it. Alright, so here we go. So again, I'm looking at 2 different vertical asymptotes, but I have to look at the behavior of the graph from both the left-hand side and the right-hand side on each of them. Alright, so now in all of these limits, the top is 3. It doesn't change no matter what x value I have, so it's always going to be a positive number up top. Now, the bottom, as I approach 2, it's going to be 0, but I want to know what is it going to do beforehand. What sign is it going to have? And as I approach 2 from the left-hand side, the negative sign, that's what it's saying, so a number like 1 1 squared minus 4 would be negative 3. So before it hits 0, it's going to be negative. So I have a positive number divided by a very, very, very small negative number. Negative infinity. Down to the bar from the right-hand side. Before it hits 0, well, a number right of 2 would be 3. 3 squared is 9 minus 4. It would be positive. So I have a positive number divided by a very, very small positive number. Positive infinity. All right, now our other asymptote of x equals negative 2. All right, so again, as it approaches negative 2, it's going to be 0. These ones are tricky because of the negative sign. Left of negative 2, so something left of negative 2, negative 3. Well, negative 3 squared would be 9 minus 4. This would be a positive. So before it hits 0, it would be positive. So a positive number divided by a very, very, very small positive number. Positive infinity. All right, and last one. We look at our denominator. It's going to be 0, but before then, right-hand side of negative 2, I'll go with, say, 0 is right of negative 2. So 0 squared minus 4, this thing would be negative. And so we take a very positive number divided by a very small negative number. Write it down here so I have room on my graph. Negative infinity. All right, so what's that going to look like on our graph? So again, drawing in our asymptotes. Here's our horizontal one. There we go. That's our y equals 0. We have two vertical asymptotes. We have one here at 2. And we also have one here at negative 2. Okay. Now our limits and our horizontal asymptote are going to tell us how this graph is going to look. So let's go with 2, our first asymptote of 2 over here. As we approach it from the left-hand side, approaching it from the left, it goes down to negative infinity. So it has to be in this portion here so that it can approach from left-hand side and go downwards. Okay, as we approach it from, the graph approaches 2 from the right-hand side, it goes to positive infinity. So because it has to follow our horizontal asymptote, it must be up in the top quadrant or top part. And again, it's going to hug our horizontal asymptote. All right, now let's look at as we approach our other asymptote, negative 2 here. From the left-hand side, we're going up to positive infinity. So hopefully the graph's not too jumbled here. And again, it's got to hug our horizontal asymptote as it goes by. And now, finally, our last limit, as we approach negative 2 asymptote from the right-hand side, this thing goes downwards to negative infinity, and so your graph's going to look something like that. And again, all I'm doing is finding my asymptotes and figuring out what the graph's behavior is from the left-hand side and from the right-hand side of those asymptotes.